Hello students, today we're going to continue our work with Chapter 6, Additional Topics in Trigonometry. Here are two triangles with some sets of information. How do we solve these triangles? So here we have side length C known, side length A known, and angle B known. If you try to set up the law of sines, it looks like this. 8 divided by the sine of angle C equals 12 divided by the sine of A, and then equals, well, side length B over the sine of angle B, which is 98 degrees. You might notice something not so great about this setup, is that in each fraction here we have one variable, which means if we take any two of these and set them equal to each other, we will have two variables and won't be able to solve the equation. If you take a look at this one, the same thing happens. When we know three sides and try to set up the law of sines, each one of these fractions has a variable still that we don't know, and if you set any two of them equal to each other, we will get an equation that we can't solve. So what do we do with these types of triangles? Well, let's take a look at the types of triangles that we've looked at. When we did the law of sines the first day, we looked at triangles like this and like this. So if you know angle, angle, side, or if you know angle, side, angle, you can use the law of sines to solve the triangle. In these two new cases, if you know side, 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 or side, angle, side, so if the angle's in between the two sides, the law of sines can't find any missing parts, so we need a new formula, and that formula is going to be called the law of cosines. And then yesterday we looked at this special type of triangle in which you know side, side, angle, so the angle isn't in between the two sides, and you can use the law of sines, but you have to be careful in this case because there could be 0, 1, or 2 solutions. So today, though, we're going to look at these types of triangles and look at something called the law of cosines, and that's what section 6.2 is about. And we're just going to look at objective 1 today using the law of cosines to solve triangles. So here is the law of cosines. We use it for, again, side, 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 and side, angle, side triangles. So if you have a triangle ABC, that's the law of cosines right there. Boom. You'll notice this first part right here looks very much like something you're familiar with, the Pythagorean theorem. And actually, the Pythagorean theorem is a special case of the law of cosines in which this thing is equal to 0 because you have a 90-degree angle, which makes this 0 right here. But there are actually two other versions of the same formula because you might want to rearrange things. This version is good if you want to try to find side length C, or if you know angle C. But let's say you're trying to find side length A. Well, then you might want, this version right here. Or you might, if you know angle B, you might want this version right here. Notice these are basically all the same, it's just what we're calling each sides that's different. So the key is that whatever side length is here alone on the left side of the equation, that angle is right here. That's opposite that side length. So if side length C is here, then angle C is here, and then the other two side lengths are here and here and here and here. And the same thing is true with all of these. And that's the case, you might have a triangle called DEF, so you might not even have a triangle with these three letters, in which case whatever side length is here, the opposite angle is here, and the other two side lengths are here, here, and here, and here. So let's take a look at how we use the law of cosines to solve a triangle. So let's say there's a triangle called ABC in which side length A is 16, side length B is 10, and angle C is 110 degrees. So I draw what I know about the triangle, and I identify, okay, this is a side angle side. Basically, what you need to do is, what I recommend doing is, if the law of sines works, use it. So if you have one of these two types of triangles, use it. And in this case right here, we do not have one of those triangles, so we need to use the law of cosines. So then decide which version you're going to use. I know angle C, so I'm going to use this version right here that has an angle C in it. So I plug in what I know into this version of the law of cosines. Side length B goes there and there, side length A goes there and there, angle C goes there, and I get the following. I then just have to solve this equation for c. And you'll notice that it's set up in a pretty good format right now. Basically, if you take the square root of each side, you'll get side length c. So you just take the square root of each side, and then you can type all of that into your calculator all at once. And it looks like this. Ta-da! And then you press enter, and there's your answer right there. And that's side length C, which is about 21.6 units. So once we know side length C is 21.6, we can then at that point find the other missing angles using the law of sines, because we now know a side length opposite an angle. So then I can set up the law of sines, but you have a few options of which angle you find next. So I'm going to use this fraction right here that does 21.6 over sine of 110, but then I have to decide whether I want to find angle B next or angle A next. And my advice would be always choose the smaller angle. Okay, so the smaller angle will be the one that's opposite the smaller side length. So at this point, I'm going to find angle B by doing 10 over the sine of B. I solve this equation, you cross multiply, divide by 21.6, and then do the inverse sign, and you get that. You type that into your calculator, and it gives you your solution 26 degrees. However, again, when you're doing the inverse sign, there are always two possible answers. You need to do 180 minus that to find the quadrant 2 answer. However, that if you chose the smaller angle, this second answer will never work, because this second answer will always be an obtuse angle, and the smaller angle in a triangle can never be obtuse. So I know that that's not going to work. And if you try to make that 154 right here, you'll see that it's way over 180 degrees, so we can rule that option out. At that point, once you know angle B, you can just subtract from 180 to find angle A, and there's your triangle now solved with all three missing parts. Next, we're going to look at an example in which we know three sides of a triangle. So here's triangle ABC with these three sides. I draw a diagram, label what I know. I recognize that I know the three sides of this triangle, so the law of sines won't work, and that means I'm going to use the law of cosines. So at this point, I have to decide which version of the law of cosines to use, and it doesn't matter. You just find any of the three missing angles first, and since I know all three sides, I plug them in for A, B, and C, and then B and C right there. And then what I'm going to do is I'm going to solve for angle A first. And it really, I can solve for any angle at this point. It really doesn't matter. So when I plug in all my numbers, I get this. Then what I'm going to do is I'm going to evaluate 20 squared is 400. I'll do 15 squared plus 8.3 squared with my calculator to get that. I'll do 2 times 15 times 8.3 to get that. And now, when solving this equation, this next step is the most common mistake. And that is, some people try to do subtraction next and actually combine these two terms. But you can't do that because this right here is a multiplication step, and you can't subtract before you multiply. For example, like if I gave you this and said, solve this equation, would you do 4 minus 3 next and get 1x? Well, I sure hope not, because these are not like terms because we've got multiplication here. That's the same idea here in this step. These are not like terms because I've got multiplication here. So what I need to do is I need to get this term over to the other side by subtracting it from each side. Then I get rid of the negative 249 by dividing both sides by negative 249. And then I will have cosine A equals this. I'm going to leave this as a fraction right now and continue solving this by doing the inverse cosine of each side so that I can type this all into my calculator all at once. When I do that, my calculator gives me this answer of 115 degrees. However, that's just one answer. You have to know that there is another possible answer. However, Cosine is negative in quadrants 2 and 3. And do I really want a quadrant 3 answer? That's an angle in between 180 and 270 degrees, which, I mean, if you think about the angles in a triangle, there's absolutely no way an angle in a triangle can be more than 180 on its own. So really, I never want any quadrant 3 or 4 answers. So when doing the law of cosines, there's just one answer you care about. So that answer your calculator gives will be the only one that you're going to want to use, so you don't have to bother finding the other angle when using the law of cosines. Once you know that angle A is 115 degrees, you can then see, okay, I've got a side length and its opposite angle here. So at that point, I'm going to use the law of sines to find the remaining parts of my triangle. Again, I'm going to choose the smaller angle here because angle C is opposite the smaller of the two remaining side lengths. So I set up the law of sines. I cross multiply, divide by 20, take the inverse sign, use my calculator. That's the answer my calculator gives me. 180 minus that will give me the quadrant 2 option. But if you check that with the angle you already have, it's way more than 180, so I can rule it out. And if you've chosen the smaller angle, it will never be obtuse, so you can just go with the quadrant 1 angle at that point. And then, last step is to find that third angle. Since I know the other two angles, I subtract from 180, and there's that third angle. So there's my solution for this triangle with those 3 missing angles. That's it for the law of cosines. Give that homework a try and email me with any questions you have.